Okay, here are some extra problems on solving exponential equations. So remember, I need to simplify, like base, set exponents equal to each other. So starting with number 1, I don't need to simplify and I already have a like base of 9. So I get to skip straight ahead to step 3, which is setting my exponents equal to each other. So 3x minus 7 is equal to 5 minus x. Get all your constants and your variables on one side, and so 4x is equal to 12, therefore x is 3. Okay, now what do you do when you have exponents that need to be simplified? Like here on number 2, on the left side here, I'm multiplying together two exponentials, so I add their exponents. So w plus 4 plus 4w plus 6, I add my two variables and I get 5w. Add my two constants and I get 10. So 5w plus 10 is going to be my exponent on the left side. So now I can rewrite that, and I have a like base of 2, so I get to set my two exponents equal to each other and solve, and this just becomes a quick little 3-step equation. And for number 2, w is equal to -3. Okay, what about number 4 though? Number 4 looks a little tricky, but it's not too bad. So I don't need to simplify, but I do need to get a common base. So on the right side, I already have a base of 5. So I need to turn the left side into base 5. And 1 over 5 is the same thing as 5 to the minus 1 power. So I can say 5 to the minus 1 power is equal to 5 to the 2c plus 3 power. And I now have a like base, so I set my exponents equal to each other. And I'm going to use algebra to solve, and I find that c is equal to -2. Okay, let's do one more. Let's do number 3. I need to find a common base, a like base. I can rewrite 64 as 8 squared. So then I would have 8 to the 6y plus 4 power is equal to 8 squared. I have my common base, so I set my exponents equal to each other, use algebra, and I get that y is going to be equal to -1/3 for number 3.